Hello students. So today we are going to learn how to reduce a matrix to normal form. Okay. So to reduce it to a normal form, a matrix is given that you have to do row operations and also column operations. Okay. Here in this method, both operations are allowed. Okay. So reducing, first you have to reduce it to identity form. Okay. Identity matrix. So sometimes you'll get the whole matrix as the identity matrix, or if you have suppose 3 by 4 matrix, okay, then you may get like this identity of this matrix and another the remaining ones 0. Okay, you have to make remaining ones 0. So from here, you can find the rank of a matrix also. That is, whatever the identity matrix you get, okay, the order is the rank of that matrix. Okay, so let's see one example. Okay, so first you have to make this 1, then 0, 0. Okay, you have to follow certain rules. That is, first you have to make this 1, then 0, 0. Then you have to make this 0. Okay, for that you have to use column operations. Then again you have to make this as 1. Then below, if you want to make it 0, you have to use row operation. Then to make this as 0, 0, you have to use column operations. Okay, so let's see. First, this is already 1. So this is fixed element. You have to make this 2 as 0. So using row operations on R2, R2 minus 2 R1, and R3 changes to R3 minus R1. Okay, so this is 1 0 0. R1 remains the same. 3 minus 2 into 2 R1. So 3 minus 4. 5 minus 6. 1 minus 4. Okay. What about this? 3 minus 2. 1. 4 minus 3. 1. 5 minus 2. 3. Okay. Now you have to make this element 0. For that you have to make use of column. So this is our first column. So we have to make use of this element. So column 1. Column 2 changes to minus 2c1. Then column 3 changes to 3c1. And column 4 changes to 2c. Okay. So this reduces to 1 0 0 0 0 0. So C2 minus 2C1. C2 minus 2C1. So this remains same. Minus 1, minus 1, minus 3. Okay. What about C3? So when you do these column operations, these two rows are going to remain the same. Okay. So this is one easiest thing in this. That is when you do column operation, these things remain same. Now to make this as 1, we have to multiply R2 by minus 1. Okay. So this is 1 0 0 0 1 1. R2 we are multiplying by minus 1. Okay. Now you have to make this as 0. Okay. So we are going in row now. Then we have to go for column. So making this 0, you have to write R3 minus R2. R3 minus R2. So 1 minus 1, 0. 3 minus, this is 3 minus 3, 0. Okay. So we are getting here the last two columns, this elements 0. So here we are not getting here 1 and we can't interchange also. Okay. So we have to stop here for the identity matrix and we have to make these two elements 0. Okay. So how to make these two elements 0? You can make use of this is 1 minus 1. Okay. See this you can make 0 by our column transformation. Okay. That is, when you go like this, you have to use row transformations, and when you go like this, you have to use column transformations. So using this one, you can make this as 0. So this is C3 it is, right? C3 minus C2. You have to make use of C2. And C4, so C4 minus C2 into 3 you have to. Okay. So the final matrix you'll get 1 0 0 0 1 0 0 1 0 0 0 0 0 0. Okay. So you have to, so this is in the form, this is our 2 by 2 identity matrix. So I2, this is I2 and 0 0 0 0 0, this is 0. Okay. So we arrived at this part. Okay. So we have reduced it to normal form, and from this we can write that what is the rank of a matrix. So rank of this matrix is 3 and here the rank of a matrix is 2. Whatever order the identity matrix you get, that becomes your rank of a matrix. So rank we denote as row of A equal to, this is the rank of a matrix. Okay. So we have just seen reducing a matrix to normal form. This is another example for a matrix to reduce it to a normal form. Okay. So let's start by making it an identity matrix. So first you have to do row operations. First you have to make this as 1. So R1 multiplied by 1 by 3. So the matrix becomes 1, 1, 3, 2 by 3, 5 by 3, 2 by 3, 7 by 3. Okay. Now you have to make these two rows 0. So R2 changes to R2 minus R1 and R3 changes to R3 minus 3R1. Okay. This is 1, 0, 0. R1 remains same. R2 minus R1. 1 minus 2 by 3. So 3 minus 2. 1 by 3. 2 minus 5 by 3. So 3 to the 6. 6 minus 5. 1 by 3. 3 minus 2 by 3. This is a 9. 9 minus 2. 7. 5 minus 7 by 3. So 15 minus 7, 8 by 3. Okay. Then R3 minus 3R1. So 3 minus 3 into 2 by 3. So 3 minus 2, 1. Again 6 minus 3 into 5 by 3, 1. 9 minus 3 into 2 by 3, 7. So 8, 15 minus 3 into 7 by 3. So this becomes 8. Okay. Now you have to make this numbers 0. So we have to make use of column operations. So starting with C2, C2, C2 minus 3 by 2 by 3, C1. Okay. C3 minus 5 by 3, C1. C4 2 by 3, C1. And C5 7 by 3, C1. So as we have seen in the last example, this row becomes 0 and this numbers remain same, right? Zero, 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 zero. Okay. So now we have to make use of row operation to make this as 1. So R2 into 3. 1 0 0 0 1 1 0 1 1 0 7 7 0 8 8. Okay. Now we have to make this as 0. So this is R3 minus R2. Okay. 0 1 0 0 1 0 0 7 0 0 8 0. Okay. Now we have to make this things as 0 as there is no number you can shift or anything. So idea we get that this is I2 matrix, that is the matrix is reduced to identity I2, okay, 2 by 2, and rest all we have to make 0. So to make this as 0 we have to make use of column. So this is our fixed element. So C3 minus C2, C4 minus 7C2, and C5 minus 8C2. Okay. So our matrix becomes 1 0 0 0 1 0 0 0 0 0 0 0 0 0 0. Okay. So this is our I2 and rest all are 0. Okay. So we can write rank also. So row of A is 2. Whatever the order of that matrix identity, that becomes our rank. Okay, so this is reducing the matrix to normal form.